Okay, so the section we're working in is trigonometric integrals, and that is how do we integrate things that are products of sines and cosines, products of tangents and secants, and products of cotangents and cosecants. And so the first thing Mr. Piaget, I hopefully talked about were the trig partners. Sines and cosines are partners, okay? They're derivatives, we involve each other. Same thing with tangent and secant, same thing with cotangent and cosecant. So these are perfect integrals because they're perfect derivatives. Then these were some trig functions formulas that you are required to know. And then I believe he did these integrals, the integral of sine squared, cosine squared, tangent squared, and cotangent squared. And so then he started to talk about the integrals that are products of sines and cosines. And so there were two cases. The first case is at least one of m or n is an odd positive integer. And in that case, let me just say something about that as a slight review. So in this case, when one of them is odd, okay, you will pull off one of the odd functions, and then you must eliminate it from the rest of the integral. Okay, so for example, you have the integral sine cubed of x cosine to the fourth of x dx. Okay, so we see that we have sine cubed. So what we're going to do is we're going to take from it and throw it away. Okay, so we'll rewrite this as the integral of the sine squared of x cosine to the fourth of x, and then the sine of x dx. And so now that we have saved our sign here, so our sine of x dx, we've saved. We already pulled from the sign, now we have to throw the sign away. So therefore, this becomes the integral of 1 minus cosine squared of x. And then we have cosine to the fourth of x. And then I have the sine of x dx. Okay, so these ones are actually rather easy. You may get bogged down a little bit in the algebra, depending upon how many powers there are to this function. But for the most part, this is a fairly reasonable problem to do. Okay, so then I'm going to let u equal cosine x du be negative sine of x dx. And then the sine of x dx will be negative du. So this now becomes the integral of 1 minus u squared times u to the fourth times negative du. It's just that simple. So this is the integral of u to the sixth minus u to the fourth du. Then you will integrate that, and you get 1 over 7 u to the seventh minus 1 over 5 u to the fifth plus a constant. And so your answer is 1 over 7. U was the cosine of x. So I get the cosine to the seventh of x minus 1 over 5, the cosine to the fifth of x plus a constant, and I'm done. Okay, so the odd case I think is the easier case because, like I said, remember, you pull one off and throw the rest away. So if I pull off a sine, I got to get rid of all the other signs in the problem. If I pull off a cosine, I got to get rid of all the other cosines in the problem. So then the second case is when they're both even, and that is when we have to make a substitution. Whenever they are both even, you must make the substitution of this formula back here. That's this. you need to use these formulas right here. Anytime you have even powers in the problem. Okay. So example, and these can be very long. You have the integral of the sine to the fourth of x, and I can even make it more exciting. Sine to the fourth of 2x, the cosine squared of 2x dx. Okay, so now I have to write this as the integral. This is the sine squared of 2x squared times the cosine squared of 2x dx. And so here's where I have to use the formula. So I'm going to use the fact that the sine squared of 2x is 1/2 times 1 minus the cosine, and I have to double the angle. So I'll get 4x, and the cosine squared of 2x is 1/2 times 1 plus the cosine, again, double the angle, 4x. Okay, so if it's a single x, it goes to 2x. If it's 2x, it goes to 4x. If it's 1/2 of x, it goes to x. Okay, so therefore, this is the integral. Now I'm going to have 1/2. So the 1/2 will get squared. So that's going to be 1/4. And then I'm going to have 1 minus the cosine of 4x, and that will get squared. And then the cosine squared gives me another 1/2. And then I'm going to have the cosine of 4x. That is incorrect. That should be 1 minus the cosine of 4x dx. And so now you have algebra to do and to multiply that out. I do know that Mr. Piaget should have covered that. If not, we can come back to it if you have a question. Okay, and then you just continue. Okay, so what I want to work on today is what in the world do you do if you have tangents and secants? That should say products of tangent, tangents, and secants, not cotangents. That should say secants. Okay, so again, we have cases. These cases are a little bit more difficult than the previous cases. Now I have tangent m of u, secant n of u du. And here I have a couple of cases. So let's just do the very first simple problem. We already know how to integrate the tangent, but I'm just going to make sure we can recall that. All right, so the first thing is very simple. That was the integral of the tangent of x dx. And if you recall, we split this into the sine of x over the cosine of x dx. And here we let u equal the cosine of x, du equal negative the sine of x dx. So the sine of x dx equals negative du. So this becomes the integral. The sine of x is negative du over the cosine of x is just u. So this is negative the log of the absolute value of the cosine of x plus a constant. And so we change this to the cosine of x to the -1. So this is the log of the cosine of x to the -1 power plus a constant. And therefore we were able to arrive at our final integral and that is the integral of the tangent of x dx is the natural log of the absolute value of the secant of x plus a constant. So as you can see, we end up with, again, tangents and secants are partners. So that is one of the reasons why we rewrite this. I apologize. I am in the wrong section here. Go back. I don't want that to be gone. Thank you. That is one of the reasons why we write this formula instead of the log minus the log of cosine, we write it as positive the log of secant, because again, secant and tangent are partners. Okay, so if we wanted to integrate the cotangent, we would do it the same way. And when we do it the same way, we get the integral of the cotangent of x dx. And now remember, cos are negative, so that's negative the log of the absolute value of the cosecant of x plus c. Again, cosecant and cotangent are partners. So we have those two formulas. Okay, so that's if we have tangent or cotangent to the first power. Okay, what do we do if we have secant to the first power? Okay, so we took care of tangent and cotangent. So secant to the first power would be the integral of the secant of x dx. And to do this one, we do a little trick. We do the integral of the secant of x, and then we multiply by secant x plus tangent x divided by secant x plus tangent x. Now we all know I can multiply by 1 and add 0 to anything I want. So as you can see, I multiplied by 1, so I have not changed the problem any. So this now becomes the integral, and in the numerator, I get secant squared of x plus secant x tangent x. I just multiplied everything out. And in the denominator, I still get secant x plus tangent x. And all of that is dx. So it is clever because u now can be the secant of x plus the tangent of x. And du, well, the derivative of the secant is secant x tangent x. And the derivative of tangent is secant squared x. And all of that is my du. Well, look, that is exactly what is in the numerator. Isn't that fantastic? Let me even include the du. Okay, so it's a perfect derivative now. It's fantastic. So we get that the integral becomes, the numerator is just du, and the denominator is u. So this is the log of the absolute value of u plus a constant. And so we now get our formula, the integral of the secant of x dx is the log of the absolute value of the secant of x plus the tangent of x plus a constant. So now we know how to integrate secant to the first power. And again, we then also know how to integrate the cosecant of x dx. It'll be the same, except it'll be a negative log of the absolute value of the cosecant of x plus the cotangent of x plus c. And again, as long as you remember who are partners, this is fairly easy to remember. Okay, before I go on, let me ask any questions, because so far we now know how to integrate sine, cosine, tangent, cotangent, secant, and cosecant. So every trig function we know how to integrate right now. Okay, any questions about that before we go on?
I'm like just confused on like how everything's related to everything. Like I feel like I was just like writing down and it just wasn't clicking in my head.
Okay, give me 1 second. Okay, so now we've done all the integrals of all the trig functions to the first power. We know how to do integrals of sine, cosine, and all of those to numerous powers. The question is, what do we do for now tangents and cotangents? So if the power of the tangent is odd, then we're going to split off one secant tangent to use as the derivative of secant. Okay, so what in the world does that mean? All right, so let's have an example. Okay, so we have something like the integral of the tangent cubed of x times the secant squared of x dx. Okay, so we see that the power of the tangent is odd. So we are going to do the same thing. We are going to split off a secant and a tangent, and then we have to get rid of everything else. Once you pull the tangent off, throw them away. Okay, so I'm going to have the integral of the tangent squared of x. I'm going to have the secant of x, and then I need the secant of x tangent of x left over. So notice I was able to grab one of the secants and put it with the tangent that I pulled off. So now that I pulled off a tangent, I have to throw away the rest of the tangents. I can't have them in the problem anymore. So this is the integral. Tangent squared is secant squared minus 1 times the secant of x. And then I have this secant x tangent x. Okay. All right, so now I can let u equal secant x and du equals secant x tangent x dx. All righty, so this now becomes the integral of u squared minus 1 times u, and then all of that just becomes du. Again, we have used the fact in this integral. I know you guys, I know it's not something you want to do, but you have to know these formulas or these rules. Okay, so this is, we use the fact that the tangent squared of x plus 1 is secant squared x. So therefore, tangent squared x is secant squared x minus 1. Okay, so we use that. All right, so now this is the integral of u cubed minus u du. So we can integrate that. So that is 1/4 u to the 4th minus 1/2 u squared plus a constant. So now we have the answer, the integral of the tangent cubed of x, the secant squared of x dx is 1/4. U was secant, so I get the secant to the 4th of x minus 1/2 secant squared of x plus a constant. Okay, so that is my answer. Okay, so that is what you do when you have the power of the tangent is odd. Okay. All right. Case 2. Well, the only other case, there are a couple of other cases that we don't do because there are integration by parts, and we'll show you that later. But this one is what happens if the power of the secant is even. Okay, so we're going to split off just one secant squared of u to make it a tangent and then throw all the rest of the secants away. All right, so if I have something like this, number 2, I don't want that to be black. Okay, so I have the secant cubed of 2x dx. So I'm going to split off, well, that should be even. Let's make it to the 4th. Okay, give you a minute to get yourself together. I think my internet's being cheap. Okay. So we have the integral of the secant squared of 2x and I'm going to split off a secant squared of 2x dx. And so now I have to throw the rest of them away. So I got to throw that away. So the secant squared becomes 1 plus tangent squared of 2x. And then I have the secant squared of 2x dx. So now I'm ready. So I'm going to let u equal the tangent of 2x. And du says, well, I get the secant squared of 2x, but a 2 comes out because of the chain rule dx. So therefore, secant squared of 2x dx turns out to be 1/2 du. Okay, so now I'm ready. The integral of 1 plus tangent is u, so that's u squared. Secant squared of x dx, well, that's 1/2 du. So this is a nice, easy integral. This becomes u plus 1/3 u cubed, and I forgot my half here. So let's put my 1/2 in front. And then I get u cubed. No, I don't. I get u plus 1/3 u cubed plus a constant. And I know u is the tangent of 2x. So now I get the integral of the secant to the 4th of 2x dx is 1/2 times the tangent of 2x plus 1/3 the tangent cubed of 2x plus a constant. Okay, any questions? Okay. Integrals of products of cotangent and cosecant are to follow the same rules as the other one. So let's do an example. So they follow the same rules as tangent and secant. All right, so let's look at this example. The integral of cotangent to the 5th of x cosecant of x dx. So now, just like when the tangent was odd, we pulled off 1. We're going to do the same thing, the fact that the cotangent is odd. So we'll pull off 1. So this will be the integral of the cotangent of x to the 4th power times the cosecant of x and the cotangent of x. And as we said, we have to get rid of all of the cotangents. So this becomes the integral, the cotangent squared of x, and it is actually squared, times the cosecant of x, cotangent of x, dx. All right, so now we have to use one of our formulas. So let's use the fact that the cotangent squared of x plus 1 is the cosecant squared of x. Okay. So this now becomes the integral. Cotangent is cosecant squared minus 1, still squared, times the cosecant of x, cotangent of x dx. So now I'm ready. So I'm going to let u equal the cosecant of x, and du what's the derivative of the cosecant of x? What's the derivative of the cosecant of x? Okay, guys, I wrote it on the paper so that this would be easy. It is cosecant x, cotangent x, but it's negative. So therefore we get this thing that we pulled aside, the cosecant of x, cotangent of x, dx, turns out to be negative du. So this is the integral of the integral of u squared minus 1 squared, and then that is negative du. So this is not a hard integral. So this becomes the integral. Uh-oh. Something got lost. Wow, that's a long spin. Okay. So it missed a few steps. This was minus du. And this is the integral. I can pull the negative out if I want. I get u to the fourth minus 2u squared plus 1 du. Okay, does everybody see where we are, despite the fact that we were rudely interrupted by who knows what, computer failure? Okay, so this is minus 1 over 5 u to the fifth minus 2 over 3 u cubed plus u, evaluate it like that. So now I can get my answer. The integral of the cotangent cubed of x cosecant, and I think that was to the fifth, I believe. And this was cosecant of x dx is negative 1 over 5, the cosecant to the fifth of x minus 2/3, the cosecant cubed of x plus the cosecant of x plus a constant. And I know that that can look pretty massive, but believe it or not, this was actually one of the nicer ones. Okay. I know this is a lot. Any questions, guys? I know this is a lot. Okay. Alrighty. Quick example. So we talked about what to do if the tangent was odd and what to do if the secant was even. Okay, so we know what to do. If the power of the tangent is odd or the power of the secant is even. But what do we do in the other case? When the tangent is even and the secant is odd? That's a hard problem. So those problems we actually end up doing by integration by parts. All right, so here's one, integral of the tangent cubed of x dx. All right, so here's one. I'm going to split off one tangent. And then I have the tangent of x dx. So now, if I can get rid of the tangent squared, I'd be in good shape because I can't get rid of tangent. So I got to get rid of tangent squared. So in the place of tangent squared, I'm going to put secant squared of x minus 1 times the tangent of x dx. Okay. So now this becomes the integral of the secant squared of x tangent of x. That's an easy one to do, dx, minus the integral of the tangent of x dx. So this is a reduction formula. You keep doing it for tangents and secant tangents to the power of an odd power. So therefore, this integral, I hope you can see it. I'm not sure if you can. But for this integral, u is equal to tangent of x, and du is just secant squared. Okay, so therefore, when we integrate it, this is 1/2 the tangent of x minus, and we already know what this is going to be. This is tangent squared. And this is going to be the log of the absolute value of the secant of x plus the constant. And we're done. We're done. The way to do these is to practice. I cannot give you a magic formula for what's going to work on these problems. You're going to have to practice. Okay. The last group are the most difficult. And that is secant to an odd power. So that's like the integral of the secant of x. Secant may be cubed of x dx. And we will pick up here on tomorrow. I will say a little bit about this and this integral and some other ones, and then we'll move on if you guys don't have any major questions. Okay. So again, I have office hours tomorrow at 3. I already have